Today starts 1.2 for us relative to the real world. So last night you had 1.2 day 1, which was a skills refresher on function notation, given equations, graphs, and tables. Today we are going to get into evaluating and writing real world with our domain and range, keeping those function notation skills in mind. Let's get right into our first example. It says Mr. Smith is driving to his hometown, top secret location. It takes 4 hours to get there. The distance he traveled at any time t, I'm going to underline that because it's defining a variable for me, is represented by this function. And as soon as I see that I'm given a function to highlight, I will highlight it. And notice it says his average speed is 85 miles per hour. Let's first define our variables. Right away, because I underlined this as I was reading, I see that t is time. But I don't want to just leave it as time. I want to be a little more specific. I see that it mentions it takes 4 hours and speed is 85 miles per hour. So I know that time is being measured by number of hours. And then d of t, even though I don't see an italicized d of t represents ... if we actually back up a step, we'll be able to see what this represents. If I reread, it says distance he travels is represented by this. So that means that the d of t represents the distance he travels. So distance traveled. And we're measuring distance in number of miles. We're then asked to write the inequality that represents the domain in real life. So as soon as I see that I'm asked for a domain, I'm just going to move this up a little bit. Our go-to strategy, folks, and I really ask that you use this to help you out. I know that domain is all about my inputs, which in this case is hours. So I know that I'm going to go back and look to see if I'm told anything about the time, the hours he's driving. So I'll reread it. It says, Mr. Smith is driving to his hometown, top secret, don't know where it is. It takes 4 hours to get there. That's going to be a restriction on the time. So I circle it and I draw an arrow because it helps me to see what it's about. Above range, I should have put number of miles before I actually went and read. So because I was given a restriction on the time, I knew that it was about the domain. If I hadn't seen anything about time, I would have gone and looked about miles. If I saw something about miles, I would have drawn an arrow to miles. If I didn't see anything about time or miles, that would have been a case where it's 0 to infinity, because then that would be the real world having a restriction. But in this case, we do have a restriction on hours, on the time, and we've got set and interval. I'm going to do interval first. So I know that at most it's 4 hours, but I need to figure out what goes here. Well, I ask myself, in the real world, what cannot be true about time? And we've had a conversation in class how we can't have negative time. So the smallest number of hours possible is 0. Translating this into set notation, it's going to be x such that, and then I get the middle part set up, and it's from 0 to 4 hours. So this was no work, came from reading. No work involved in this one. So I know something about the time, but now I don't know about the miles. So our strategy is to plug in. Remember, these are both x values. So we're going to plug in these x values one at a time to find the miles using this equation. So first we'll do d of 0 equals 85. And so where I see t, I see that I'm going to plug in a 0. that equals 0. If I were to write this as an ordered pair, I plugged in this x and I got out that y. So that would be 0, 0 as an ordered pair. And then if I were now to plug in my largest x value, d comma 4, excuse me, d of 4, d of 4 equals 85 times 4. And you can either do this out on the side of your paper, or feel free to press pause and go get your calculators. So press pause if you need to. 85 times 4, when we do that out on the side or using our calculator, we get 340. And again, if I was looking to build an ordered pair, this was my x, I plugged in that x, I got out that y. So this would be 4, comma 340 as an ordered pair. And I make mention of this because if I did ask you to graph, these would be the two ordered pairs I'd look to graph. But for us, we're just asked for the range. So when I look, I've got 0 and I've got 340. This is my smallest y value and my largest. And I use it to build my range, 0, comma 340, where both ends will get a bracket. Translating this into set notation, the middle never changes here. 0 to 340, and I close it. Both get a line underneath because I can drive at most the 340 miles, and 0 is the real world minimum smallest value on miles. How long will it take him to get to his hometown? This we get from reading. It told us it takes him 4 hours. So 4 hours. And then, hey, check it out. Look at this question. Write two ordered pairs you could plot. Here they are. 0, 0, and 4, comma 340. So really understanding that idea of function notation, that when we have d of a number, that's an x value. Whatever answer you get out is the y value attached to the x value to build x, comma, y. Let's look at number 2. Mrs. Smith disagrees with Mr. Smith's 4-hour estimate. She knows that from where they are, it's approximately 168 miles to get to his hometown. The distance he travels at any time t, so I'm going to underline that, is represented, I should have split that up. So time t is one of your variables, distance he travels is the other, is represented by this function. So I'm going to highlight this function. Write the inequality that represents the domain, and write the inequality that represents the range. If you notice, it didn't ask me to define variables, but we are always going to do so, even if it's not asked of us. So off to the side, t is time. We're still talking hours, so time in hours. And d of t is the distance traveled, because it says the distance he travels at time t is represented by this, and d of t equals that. So that's how I know that these two things are connected. So d of t is distance in miles. To figure out how I can go about reading for information, the crucial, most important step is to put real-world meaning to the domain and the range. My inputs, t is time, so I'm going to put number of hours above domain. And then my range, my output, is all about miles, so I put number of miles above where I see range. So now I'm going to go back and reread for information and see, am I told some kind of limit on the time it takes to drive or on the miles? So let's go back and read together. Mrs. Smith disagrees with the 4-hour estimate. She knows that from where they are, it's approximately 168 miles to get there. And then the distance travels at time t, represented by this function. So I here am told about a max distance of the miles. I'm told that. So I ask myself, well, if this is a distance in miles, is that a value for hours or miles? And because I added these labels, it is super obvious to me that this is going to be a value for where I wrote miles, over the range. So here we're given something for the range. The total trip is 168 miles. So if I work on my interval notation, that's going to be 0 to 168 because 0 is the smallest possible number of miles. We can't have any negative miles. And then I'll translate that into set notation. We're given this automatically. 0 goes here, 168 goes over here, and both get lines underneath. So just like you wrote a note up here, no work came from the reading, this time the range had no work came from reading. So now I've got the y values and I have to go find x. When that happens, we are going to let first y equals 0 because that's my first y value. So that's going to mean, remember, all of this represents y. Function notation still just represents y. So this entire side of the equation becomes 0 equals 85t. And now let's solve. 85 times t, the opposite of multiplying is dividing. So I will divide both sides by 85. And I get 0 equals t. That's one value for my range. To go find the other value, I will plug in the one I haven't done yet. So this was the first value for the range. This is the second. So now let y equal 168. So now, instead of this entire side becoming a 0, it's going to become 168 equals 85t. If you haven't gotten your calculator yet, it would be good to, because we need to divide both sides by 85. Press pause if you need to go get it. On my calculator, when I do 168 divided by 85, I get 1.98. And we found the values we need for the domain. Notice, right? T equals 0, t equals 1.98. So 0 to 1.98. And then translating that into set notation. 0 goes on the left, 1.98 goes on the right, and I'm all done. Write 2 ordered pairs you could plot. So to get those ordered pairs, let's go look at our map. Remember, this is my y value. I found x. So if you want to put some little labels and highlight, this is x, and then there's y. This is x, and this is y. So my first one would be 0, 0, and here 1.98 because that's my x value, comma, the y value, 168. So then I just fill in these 0, 0, and 1.98, comma, 168. So always get your ordered pairs from the algebra you do. Will they get there sooner or later than Mr. Smith predicted? Explain. Well, let's see. Mrs. Smith calculated how much time. Remember, the real world meaning of this would be 1.98 hours. Go look and see what Mr. Smith thought. Let's see, if we go back up, Mr. Smith said it took 4 hours. So who wins? Yes, they will get there sooner. Ms. Smith calculated will only take them 1.98 or approximately 2 hours to get there. So if it's about 2 hours, think about the relationship between that 2 hours and the 4 he predicted. So that's roughly half the time. Before we leave this page, this is a great opportunity to see one on top of the other, the two possibilities. So in the first part, number 1, I was given the domain and I had to find the range. So somewhere big and obvious, let's put that in like a bubble. So this first one, given domain, find the range. I might even highlight that to make it stand out. But then I look at number 2 that we just did. Instead of being given the domain, I was given the range. We were given values for y. See how we had to plug in the y values? So for this one, given the range, I just want to make the language match. Find. Oops. Given the range, find the domain. So if anybody needed some help on the past real-world questions we've done in our Unit 1 workbooks, almost every single question is going to be either one or the other of what we just looked at. You're either going to be given the domain and you have to go find the range, or you're given the range and you have to find the domain. The key strategy, folks, I can't stress it enough, is labeling the domain and range. Like actually label the words, and then when you go read for information, it'll stand out to you whether or not the given restriction is for domain or range. So this, what I'm highlighting right now, is the key strategy to help us read for information correctly and then use that information correctly. That wraps it up for Mr. and Mrs. Smith. Let's work on filling out this box at the top. To help define the variables, look for the phrase y per each or every x. And this is a phrase we're going to say a lot. So I'm actually going to write it up here and highlight it, so that if you ever want to look back into your notes, you'll see where we first started talking about this. This is a great strategy to help us add to our toolbox in terms of being able to define variables correctly. Y per x, or y each x, or y every x. So per, each, or every will be the words we look for in the actual real world problem. These represent the x and y variables. For example, people each year. So in the back of your mind, if you're thinking y each x, like to the left of the word each, you put y, and the right x, people is my y variable, and year is x. Y each x. So per, each, or every is kind of that buzzword that'll be in the middle. This numerical value will also represent the slope, so be on the lookout. What were those three keywords? Per, each, and every. The slope is the rate, it will increase or decrease, the rate of change. We should all recognize that, hopefully, from Algebra 1. Our slope, which is represented by the letter m, is also known as our rate of change. And our y-intercept, which is b, is our initial value. And I'm going to pause right here at this box because number 3 will be in our debrief tomorrow, and we'll be working on this question together at the start of class. So this has been a really good flipped video to help us capture and summarize all of our current knowledge. By means of the Mr. and Mrs. Smith question, we really have captured the big picture of every single real-world question we've looked at up until this point, where, as we put in red and highlighted here, you're either given something about the domain and you had to go find the range, or you were given the range and you had to go find the domain. The new piece of information we're learning tonight is this idea of y per x, where when I said per, it could be per, each, or every. And starting with tomorrow's debrief question, just to kind of give you an idea of where we're headed, if I look at number 3, I see no given equation. There's no given function. So as of tomorrow, if you look right here, we will be responsible for writing our own linear equation. If you have an idea and you'd like to get ahead and maybe try number 3 on your own, feel free. Otherwise, we will be starting right up here first thing tomorrow as our debrief question. Have a great night, and any questions, please shoot me a remind. See you tomorrow.